Imagine a world plunged into darkness. The familiar hum of electricity fades into an unsettling silence. Our smartphones, rendered useless, reflect only our worried faces. This is not science fiction, but a potential reality if a powerful solar storm were to strike Earth. Our sun, the lifeblood of our solar system, is not always a benevolent star. It is capable of unleashing bursts of energy that could cripple our technology-dependent world. These events, known as solar storms, are a stark reminder of our planet's vulnerability in the face of cosmic forces. The consequences of a major solar storm could be far-reaching, impacting everything from communication systems to power grids. Our interconnected world, so reliant on technology, could be brought to its knees in an instant.
Solar storms are essentially giant bursts of energy from the sun's surface, releasing immense amounts of heat and light. These eruptions are often associated with intense magnetic activity, such as sunspots, which are regions of the sun with strong magnetic fields. Sunspots are cooler, darker areas on the sun's surface, appearing as dark patches due to their lower temperature compared to the surrounding areas. One key component of a solar storm is a solar flare, a sudden, intense brightening of the sun that releases a tremendous amount of energy in the form of radiation, including X-rays and ultraviolet light. Solar flares can disrupt radio communications, interfere with satellite operations, and pose a significant radiation hazard to astronauts in space. Another component, and arguably the most dangerous, is a coronal mass ejection, or CME, which involves the ejection of vast amounts of solar material. CMEs are massive bursts of plasma and magnetic field that erupt from the sun's corona, the outermost part of its atmosphere, and can carry billions of tons of solar particles. Traveling at millions of miles per hour, CMEs can reach Earth in a matter of days, potentially causing significant disruptions. When a CME hits Earth's magnetic field, it can cause geomagnetic storms, which are disturbances in the Earth's magnetosphere. These storms can induce powerful electric currents in long conductors, such as power grids and pipelines, leading to potential damage. Geomagnetic storms can potentially lead to widespread blackouts and infrastructure damage, affecting millions of people and causing significant economic impact.
The Carrington event of 1859 stands as a stark reminder of the destructive power of solar storms. In early September of that year, a series of intense solar flares and CMEs bombarded Earth. The most powerful of these events triggered auroras, typically seen only near the poles, as far south as the Caribbean. Telegraph systems, the cutting-edge technology of the day, went haywire. Operators received electric shocks, telegraph paper spontaneously caught fire, and some systems continued to operate even after being disconnected from their power sources. While the world in 1859 was far less reliant on technology than we are today, the Carrington event provides a sobering glimpse into the potential chaos a similar storm could unleash on our modern world.
Some scientists believe that the sun's activity cycle is currently ramping up toward a peak in 2025. This period of heightened activity could lead to more frequent and intense solar storms, potentially putting Earth in the crosshairs. While predicting the exact timing and intensity of solar storms remains a challenge, the possibility of a major event in 2025 underscores the need for preparedness. The potential consequences of a Carrington-level event today are staggering to contemplate. Our reliance on technology has grown exponentially since 1859. A major solar storm in 2025 could disrupt global communications, ground air travel, knock out power grids, and disable satellites, plunging us into a world of uncertainty and disruption.
Section 5. Technology's Achilles heel. Our modern society is intricately intertwined with technology. We rely on it for communication, transportation, finance, healthcare, and countless other aspects of daily life. This dependence, however, has also made us increasingly vulnerable to the whims of space weather. Satellites orbiting high above Earth are particularly susceptible to solar storms. The intense radiation and charged particles released during these events can damage sensitive electronics, potentially crippling communication and navigation systems. Power grids, the backbone of our electrified world, are also at risk. The massive currents induced by geomagnetic storms can overload transformers and other critical components, leading to widespread blackouts. The interconnected nature of our technological systems means that a failure in one area can cascade rapidly, amplifying the impact of a solar storm. A disruption to GPS satellites, for example, could disrupt not only navigation systems, but also financial transactions and emergency response efforts.
Section 6. The domino effect, disruption, and chaos. The potential consequences of a major solar storm on our technology-dependent world are far-reaching and potentially catastrophic. Imagine a world without internet or cell phone service, where ATMs are useless and credit card transactions impossible. Hospitals reliant on backup generators could face difficult choices as power outages drag on. Air travel would grind to a halt, stranding passengers and disrupting supply chains. Food and water distribution could be impacted, leading to shortages and unrest. The economic impact of a major solar storm could be devastating. A 2017 study by Lloyd's of London estimated that a Carrington-level event today could cost the global economy trillions of dollars. The disruption to supply chains, loss of productivity, and cost of repairs would be felt for years, if not decades.
The threat posed by solar storms is not a matter of if, but when. Recognizing this, governments and organizations worldwide are taking steps to prepare for the inevitable. One crucial aspect of preparedness is improving our ability to predict solar storms. Space agencies like NASA and ESA are constantly monitoring the sun, using a fleet of spacecraft to track solar activity and provide early warnings of potential threats. Another key area is hardening critical infrastructure against the effects of geomagnetic storms. This includes protecting power grids with voltage regulators and surge protectors, as well as developing backup systems that can kick in during outages. In addition to these technological solutions, public awareness and education are vital. In the event of a major solar storm, individuals will need to be prepared to be self-sufficient for extended periods, with access to essential supplies like food, water, and first aid.
While the Carrington event stands out for its intensity, Earth has experienced numerous other solar storms throughout history, some of which have come dangerously close to causing widespread disruption. In 2012, for example, a powerful CME narrowly missed Earth. Had it struck, scientists believe it could have caused widespread blackouts and disrupted communications for months. This near miss served as a stark reminder of our vulnerability and the importance of preparedness. The good news is that each solar storm, whether a direct hit or a near miss, provides valuable data that helps us better understand these events and improve our forecasting and mitigation strategies. By studying past events, we can learn to better anticipate and prepare for the storms of the future.
Predicting space weather, much like predicting terrestrial weather, is a complex science that is constantly evolving and requires a deep understanding of various factors. Fortunately, advances in technology and our understanding of the sun have significantly improved our ability to forecast solar storms. Spacecraft like NASA's Solar Dynamics Observatory, SDO, and the Parker Solar Probe provide a constant stream of data on the sun's activity, allowing scientists to track sunspots, solar flares, and coronal mass ejections, CMEs, in real time. This continuous monitoring is crucial for anticipating space weather events that can impact Earth. Sophisticated computer models are used to analyze this data and predict the path and intensity of solar storms. These models take into account numerous factors, such as the speed and direction of CMEs, as well as the orientation of the sun's magnetic field. By integrating this information, scientists can make more accurate predictions about potential impacts on Earth's magnetosphere and technological systems. While our forecasting abilities have improved over the years, there is still considerable room for growth. Accurately predicting the arrival time and intensity of a solar storm, particularly a major one, remains a significant challenge. The dynamic nature of the sun and the vast distances involved add layers of complexity to these predictions. However, ongoing research and technological advancements promise to further enhance our space weather forecasting capabilities. Scientists are continually developing new methods and tools to better understand and predict solar activity, which will ultimately help protect our technology and infrastructure from the adverse effects of space weather.
As we approach the predicted solar maximum in 2025, the question remains, are we ready? The answer, as with many complex challenges, is not a simple yes or no. It involves a nuanced understanding of both our capabilities and our vulnerabilities. We have made significant strides in understanding and preparing for solar storms. Our ability to forecast these events has improved, and we have taken steps to harden critical infrastructure. This includes reinforcing power grids, enhancing satellite protections, and developing early warning systems. However, much work remains to be done. Public awareness of the threat posed by solar storms is still relatively low. Investing in research and development of new technologies to protect our power grids and communication systems is crucial. This means not only creating new solutions, but also ensuring existing systems are robust enough to withstand potential disruptions. International cooperation is also essential to ensure a coordinated global response in the event of a major solar storm. The year 2025 may not necessarily be a year of disaster, but rather an opportunity. An opportunity to unite nations, share knowledge, and develop comprehensive strategies that transcend borders. an opportunity to test our resilience, to push the boundaries of our knowledge, and to work together to mitigate the risks posed by our increasingly technology-dependent world. The sun, in its own fiery way, may be reminding us of our place in the cosmos and the importance of respecting the forces of nature. It is a call to action, urging us to be proactive rather than reactive. Ultimately, our preparedness for 2025 and for the solar storms that lie beyond will be a testament to our ingenuity, adaptability, and collective will to safeguard our planet and our future. It is a journey that requires dedication, collaboration, and an unwavering commitment to protecting our world from the unpredictable, yet inevitable challenges posed by the cosmos. If you found this video informative, don't forget to like and subscribe for more updates on solar storms and other cosmic phenomena. Stay prepared, stay informed.